Hey everyone, welcome to the VMware Cloud Networking Academy presented by 27 Virtual. Today's topic is securing applications in the modern era. Presenting today is yours truly, William Grismore, NSX-T architect. And I have with me today Andrew Grismore, NSX-T vExpert. And I'm going to turn it over to Andrew.
Hey everybody. So what we're going to start off with before we get into the meat of the NSX-T security capabilities is just take a step back and look at segmentation from a traditional standpoint. So what we're looking at here are our traditionally segmented application tiers. So we have our web tier, our app tier, our DB tier. They may be on 3 separate VLANs. And if we're going to provide any type of segmentation between them using a firewalling device, then in that traditional type of format, we'd typically be steering traffic to a firewalling device like a Palo Alto physical firewall and enforcing policy there. Now, I say if because it's very difficult using those traditional types of tools from a physical standpoint for a lot of organizations to be able to implement east-west traffic flow policy. And by east-west, in this case, I just mean internal to your north-south firewall, east-west traffic flows from one VM to another, because it's just tough. Usually what we'll see for most customers is that if they don't have a team that is actually dedicated to monitoring, understanding, and creating rules for these east-west flows, then it really doesn't get done. And it's really even tough to get initial visibility into these flows when for so long we've been concerned with the north-south traffic coming in and out of our data center. But what we've seen over the past few years is that the real goal for attackers now is to get in however they may get in, whether that be internally or through your physical firewalling device, whatever it happens to be. A user accidentally clicks something in an email, however they get in, they get into your east-west environment, and their goal is to spread. So unless you are dedicating a team using that physical firewalling device to segment between these tiers, then you're going to be in a scenario where you're wide open. On top of that, even if you are going through the process of arduously monitoring these flows and creating rules using that physical firewalling device, you're still left open internal to the segment. So if we look at the web tier and these flows between VMs and the app tier and these flows between VMs, that is still going to be wide open because there's no layer 3 move to get us to that physical firewalling device when we go from VM to VM on a single segment. So what we want to do is break that mold. We want to be able to say, we're going to control all of the flows to and from our workloads, and it could be VMs like we see here, but we'll see that with NSX-T, we can even go above and beyond securing just our virtual workloads and really control how they communicate totally. And we want to do it at an individual level to those workloads. And the way that we're going to do that is utilizing the capabilities of NSX-T. We're going to look for commonalities. So you see shared services, look for commonalities possibly from a user standpoint, because we can enforce rules based off of user in NSX-T, and really granularly understand flows to and from our VMs using the capabilities, again, that we have in NSX-T and the tools that VMware provides us, and control those flows to and from our workloads. All right, so we want to move to a more modern model. So here's what we really want to be doing. We want to be able to, as you see here, enforce firewall rules individual to the workloads. Now, what we're going to do is we're going to look for those commonalities. We're going to start off by addressing the shared services that everything is going to need, such as Active Directory, NTP, DHCP, DNS, those types of broad level services in the data center that everything's going to need access to, and make sure that they are accessing those services properly. And then we can, again, go in and identify and drill down what are the commonalities that we see with our workloads. If we have the ability to control every single flow to and from our workloads, we need to have a way to organize that and to make it so that our rule set is as efficient and simple and manageable as it can be, while also taking advantage of the power that we have across every single, in this case, VNIC of our virtual machines. So we have to get in there, identify commonalities. In this example, and this is just one way you could do it, and what we'll come to find is that you may use multiple commonalities to define policy on a single VNIC. But in this example, we have finance, HR, and engineering to define a commonality. And we can create tags that correspond to groups to allow only the traffic flows that we want to see both within and across those groups. So regardless of the network that our workloads sit on, we are going to create rules specific to their actual needs, not rules based off of the network, rules based off of the functionality of the workload, and create policies based on that so that we can repeat it as we continue to deploy those workloads as well. All right, Bill, you want to talk about some of the capabilities that we have in NSX-T when it comes to what we're going to enforce that and the types of rules we can use?
Sure. What we want to do right here, Andrew, is we want to make sure that we have the enforcement not only on the VMs, but also on container-based workloads as we go to the modern application era. We can even install agents on bare metal. A very, very interesting feature that's now new in NSX-T 3.0 is we can actually install an agent on a Windows bare metal server as well. So we support Linux, Red Hat type based physical bare metal servers, and now Windows. And we can even extend security with the proper tools in NSX-T into the native public cloud, as well as VMware cloud destinations, which is just referring to different types of service providers like IBM Cloud or any of the other VMware cloud providers that are out there, of the 4,000 VMware Cloud Provider Services Network. Any of those type of platforms will work as well because they're native vSphere, native NSX-T. And then in the native public cloud, we can leverage, again, an agent-based tool and an appliance to be able to have security so that you can actually have a VM sit on-prem. You can migrate that VM to the native public cloud or into like a VMware cloud on AWS, a VMC on AWS solution, and maintain that security. The one thing I do want to emphasize that's really important about the security is that when you look at where the security actually takes place is very important. So in the core infrastructure, on the VM itself, we have the VNIC in the VM. And sitting outside of the VM, we actually have slots, and there's 16 slots that sit right here. And we're not installing an agent in the VM in this scenario. Now, in the native public cloud, we don't have any choice. But in our VMware cloud destinations or on-prem or our colos, on those virtual machines running on vSphere platforms, there are no agents installed. I always used to like to say, look, mom, no agents. And the reason that's important is we're taking the security controls and we're placing them in the hypervisor. So the security controls sit in the kernel of the ESXi host. One analogy I heard one time that I thought that was really good is that if you think about your home, for example, and you have an alarm system, if somebody were to break into your house, they potentially could get in and disable the alarm because it's visible to them when they come in. Or maybe it's attached on the outside of the house somewhere. What we're basically saying here is we're going to take that security and we're going to bury it in the backyard where nobody even knows that it exists. So when somebody comes into the VM or they come into your house, that security is intrinsic and it's built in to the hypervisor versus being bolted on. So we can connect and protect our VMs and move them anywhere in the environment. And we can leverage that as a very strong tool to make sure that we follow the workload no matter where it goes. We can use standard 5-tuple rule sets. We can define the segmentation on the VM on the same segment. And then the other thing too, back on this previous slide, right? What you can do here is we can actually have security between VMs on the same segment, which is huge. And Andrew, why don't you talk about this next slide for me here?
So to continue on with Bill's point, what we're seeing is that ability to enforce individually on our workloads, and those workloads with NSX-T, as we differentiate ourselves from NSX-V here, we can do those containers. We can have a single pane of glass where we push policy that is identical for our on-prem workloads and for what's happening in the cloud. And on top of that, it doesn't have to be ESXi hosts. So you see we've got bare metal servers, we've got our KVM hypervisors in here. So we're expanding out the scope of the policy that we're pushing to have it so that we're covering our workloads wherever they happen to exist. We know that a huge goal of networking with NSX-T is to make it so that our networks exist wherever our workloads need to exist. We also want to make sure that security policy is available for them wherever they happen to go as well.
Yeah, and the other thing, Andrew, do we have to hairpin anything to any physical firewall to make this work?
Not at all. Everything that you're seeing in this picture is plenty to get the job done.
Now, does that mean I get rid of my physical firewalls, though? Do I still, I mean, if I have this, do I still need my physical firewall?
Well, ideally, you're going to continue to let your physical firewall do its job. You set that up, you have rules in place for that north-south traffic, and we're not saying that you should get rid of that. It's not that you couldn't enforce the rules down here. You could if you wanted to, but we probably want to keep that physical firewall in place, let it do its job, because it's looking at all the traffic that has to go through it to get out of your environment. So you have a centralized set of resources to do that, and maybe some really cool technologies and capabilities with whatever vendor you may happen to use there. But what we're saying is you now have the additional capability to enforce traffic inside of your data center, so that if for whatever reason you are breached, you have additional layers upon layers of security built into your east-west traffic environment.
All right, so you're saying I'm going to keep my physical firewall because I've got to have that. I need my physical firewall to stop those denial service attacks. And then I'm going to have that extra layer on the inside so that stuff doesn't spread laterally within my environment. Is that basically what we're saying here?
Exactly. And it's not even just that it's one layer. Depending on how far you take this, you could build bubbles inside of bubbles inside of bubbles to really lock down the traffic that you've got going on.
I got another question for you here. So is this something that's only for NSX-T based networks? So, I mean, do my workloads have to be on these new NSX-T Geneve based segments or not?
Yeah, that's a good question. It's something that we're going to look at in just a little bit. But the main thing to know about NSX-T and what you're seeing in this picture here is that our workloads do have to be plugged into that NSX virtual distributed switch, or the NVDS. So regardless of if it's using a traditional VLAN backed network in that NVDS or the overlay segments that we can create, as long as you're plugged into that NVDS, you're good to go. So be aware that if you are using NSX-V for only firewalling and you want to use NSX-T, you need to be on an NVDS to be able to do that.
Right. And also coming out soon in vSphere 7, if it's not already out yet, in vSphere 7, I think there's going to be a minor change there as well.
Yeah, we should get the normalized VDS so that we can continue to do very similar activities to what we saw in NSX-V, where you can just use that VDS that you get in vSphere, keep your VMs on VLANs, and still be able to micro-segment with the distributed firewall capabilities.
So what are we looking at here, Andrew?
So what we're seeing here, just to quickly go over this, is a visual view of how we actually enforce policy. So I mentioned earlier that the goal to be able to actually start writing rules is to find commonalities. So what you'll notice is that when we look at the source and destination specifically in this example, and it's going to read like many other firewalls that you would look at. So you'll have the name of the rule, the source. You'll notice the source, if we have something specified other than any, it's going to be a security group in here. And that security group comes from the tagging that we do where we identify commonalities. So we'll have a source in here. We'll have a destination, same thing. We're looking at security groups. And then we'll define the service. So we'll say, in this case, HTTP, the port and protocol that we're trying to specify here for what we want to allow or deny. And then we will choose if we're going to allow or deny or reject that action. So the last thing that you see in here is the apply to, and that gives us the ability to control the scope of our rules and make sure that we're enforcing it only where it needs to be. So just an overview here. I highly encourage you guys to hop into a lab if you can to get a better feel for the interface. But usually from all the classes that we've taught and the customers that we've worked with, it really only takes a few minutes to actually get familiar with it and start using the firewall effectively.
Yeah, the great thing about the firewall feature in NSX-T, you can deploy NSX-T, and as long as you have that NVDS the way it currently is, or in the normalized VDS in vSphere 7, you can basically deploy this very quickly, prep your host, and start using this micro-segmentation right away. Isn't that right?
Exactly.
So we can see here that we have an external router, and they're showing the east-west firewall for VLAN-backed workloads. So I guess the point here is that we can definitely implement security both on the NSX-T segments that we build that are these networks that can be stretched, and I can do the VLAN-backed workload. So, you know, would it be better to have both the micro-segmentation and the NSX-T segments and kind of get the best of both worlds together and get that benefit? It sure would. But if I'm not looking to leverage the software-defined networking itself, I can still leverage security on these VLAN-backed workloads. So it's important to understand that whatever VLANs you currently have in your environment, you can still use those and you can still secure them. Those VLANs will still be connected to an external router. There will still be a physical firewall that you can take advantage of. But now in addition, I can also put that micro-segmentation right on that VNIC in the kernel of your host and get that extra protection. And the bullet here is important. So if I'm migrating workloads from an old platform to this new, whatever the case is, I'm able to maintain that VLAN. I can keep it. I don't have to, you know, re-IP anything. And I can implement that security right away and get that east-west security that we get with the micro-segmentation.
Yeah, it allows you to take a phased approach. If security is your #1 goal, and that's why you're watching this presentation today, you can start with security. You're going to have the networking features, but you can always keep your VLANs and start with security. And then when you decide you're ready for the network virtualization, you've got your design in place, you can move forward with that.
Yeah, absolutely. At some point then we could, maybe at some point in the future, if we don't want to use this external router anymore, we could very easily take these segments and drop them onto the NSX-T segments and take advantage of the routing and switching that NSX-T gives us. Or I could just choose to leave them here depending on what my particular use case or business need is. And this is good because it's showing you here on this next slide, Andrew, we're taking a look at the NVDS and then the VDS in 7. So we can see that if you're on an ESXi 7.0 host, we have this normalized VDS where we can actually have our regular VLAN port groups in here without having to drop them into the NVDS. So if
Absolutely. It makes life a little bit easier.
So if it's a little bit older, those VLAN back port groups have to be in the NVDS, and your segments, of course, will be there. In the newer version, we don't have to worry about dropping them into the NVDS. It definitely makes it a little bit easier.
So let's talk a little bit about how we actually achieve micro-segmentation. So how do we get to the point where we're actually creating security policies in the distributed firewall and enforcing those rules? Well, it all starts off with making sure that we actually have the ability to enforce those rules on the host, and in order to do that, we have to prepare those hosts for NSX. So we have to make sure that the kernel has the software capabilities to actually enforce the distributed firewall. So we'll start there and make sure that we have prepared our hosts. Then we'll create our segment where necessary. So it could be on the NVDS or the normalized VDS. Make sure our virtual machines VNICs are plugged into that appropriate network. And then once we have that, we can start actually enforcing rules. But there is plenty between that move VMs and the right security policy, because we first want to make sure that we actually understand the flows of our virtual machines and really have a good idea of what those commonalities are before we start just writing random rules. But this is how we get to the point where we can say, hey, from VMA to VMB, block that traffic. This is all the steps that you need.
I got a quick question for you right here, Andrew. So how do I figure out how to write these policies? It seems like there's a lot of complexity in creating those firewall rules. That slide we had up earlier, you were showing, some rules being created. How do I know what to put in for the port and the protocol? How do I figure that out?
Yeah, so that is the flow discovery piece of getting to the point where we can write security policy. And for those of you who have attended any of our previous virtual cloud networking over the past 2 years security events, I've gone into great detail on how we get to that point. But to sum that all up, we have tools like vRealize Network Insight, we have NSX Intelligence that we can use to get a better idea of how our workloads are actually communicating and use that information in combination with a solid design based off of the commonalities that we saw before, tagging and grouping as you're going to see here, and then we can actually start writing those rules. So this is where we can really take advantage of those commonalities and the tagging and grouping capabilities that we have and the additional information that we get when we learn the flows and use those in combination to develop a methodology here to actually utilize the distributed firewall in a way that's manageable for your security administration team. So if we take a look at what we have here, we could use an example that we have a web virtual machine in production that needs PCI compliance, just to go along with the example that we have here. And we can make sure that those tags are appropriately assigned to the virtual machines based off of the functionality of that VM. And then again, based off of the functionality of the VM, it will only be able to communicate over the network in a certain way. So we could have an application tier or an application tier VM in development that doesn't need anything else, and it will be tagged appropriately there. And again, get the appropriate policy pushed out based off of the fact that it has those tags. It automatically joins the group, and we have rules written using those groups. So it all comes together, and we use the flow information to appropriately assign the services that we're going to allow for those groups. We want to use all this in combination. We want to gather as much information as we possibly can and learn flows from the actual wire so we know exactly how we're communicating, determine what we want it to do based off of the functionality of the workload, then assign the appropriate tags and make sure that the rule makes sense for those groups. So here's a look at an example of what we could have done. You can see that we have our source is an IP set or a logical switch, or preferably for me, a group based off of tags like we see more toward the bottom. And we'll use that as the source or the destination, learn the flows, and enforce the correct services based off of what we want the functionality of that group to be. And it's all based off of what we learn from understanding the flows based off of the previous traffic that we've seen and allowing only what we want to flow here.
So here we have the application ID firewall. So the idea here is to take this to the next level. And what we can do with NSX is pretty amazing, just what Andrew covered so far. So everything so far we're looking at is layer 2, layer 3, and layer 4. So layer 2 is your MAC address. Layer 3 is your IP address. Layer 4 is that default or main port that you're using. We do have the ability to leverage a predefined list of around 100 or so different application IDs, and that list is going to grow to about 250 very soon to over 1,000. And you're even going to have the ability to capture traffic flows and build your own specific application ID over time. So what this allows us to do is, instead of just blocking traffic on a well-defined port like 443, we can actually specify the service type that we're looking for. For example, TLS, and I can even be as specific to specify the version of TLS that I'm looking at. So instead of just looking at a port, I'm actually looking into the frame and identifying the actual traffic flow to give me a very strong layer 7 capability. Now, a lot of the third-party vendors, if you have a Palo Alto firewall or a Checkpoint firewall, they're very good at this, and you may still maintain that. But over time, as this feature improves and becomes richer, you'll have the opportunity to leverage this feature within NSX itself. The benefit being that it's, again, not a central point. This is a distributed layer 7 security feature that spans across all your different hypervisors. So it gives you some pretty strong capabilities there as well. This can also be combined with whitelisting, where we can actually define something that's already well known that we can allow, and we can keep adding to that whitelist and then combine this with looking for specific application IDs. So the combination of everything together is very powerful there. And the point of the magnifying glass here is just to show you we're actually looking into that packet and inspecting what's going on instead of just trusting that the port is right. Because if it's 443, whatever that number is, we don't really know for sure that it's truly 443. The packets moving across the network, they all look pretty much the same. We have to have some way to identify what's actually going on. So that's a very powerful feature. And then we can also see here the traditional way that I just mentioned, layer 4. We're looking at the well-defined service. And when we go in to create the actual firewall rules, you can pick those well-defined services. You can also specify your own if it's a unique service ID number or port. And then we have the application ID that we just talked about, where I can do just port-based enforcement. We have a new feature in NSX-T in the profile section where we can actually define the layer 7. And then in the middle here, we have kind of the best of both worlds. We're doing the basic layer 4 port ID, which narrows the scope, if you will. So we know that it's that port. And then we take it to another level on the profile section where you actually can dive into the frame and get more details and get the best of both worlds. So it makes it truly very, very powerful when you start implementing these additional security features. All right, on this next slide, we're going to talk about identity firewall for NSX-T data center. So far we've talked about micro-segmentation, east-west security, layer 2 MAC address, layer 3 IP address, layer 4 port, layer 7 capability, the ability to look into the frame and see what's going on and control traffic flows. There's a lot of great features there, protect our core applications in our environment and our DMZ, you name it. But what about the ability to have, say, somebody come into your organization, like a consulting firm, and when they log in, I'd like to, based on their identity, say they can only get to XYZ. Or maybe I work in a medical facility and I want the doctors to get access to this application and the rest of the healthcare staff to have access just to this application. Or maybe they both have access to the same application, but just different components or different modules, because some of those applications can be quite large. So how do I do that? Well, what I can do in NSX-T is I can leverage the integration between Active Directory, so Active Directory is a requirement, and a desktop. So in environments where you have virtual desktops in place, this becomes very, very useful. So with virtual desktops, when I log into my virtual desktop, I can leverage taking advantage of these identity-based firewalls or firewall rules that I've implemented to control who has access to what. Another example of how I can use this, also based on identity, is when a user logs in through remote desktop, based on their identity, I can control what applications they have access to through an enforcement policy. Now, one thing that's important, when NSX first came out, one of the drawbacks of remote desktop-based security is that once somebody came through the remote desktop session host, we couldn't identify into the traffic flow the specific user, because multiple users will connect to that same session host. So now we can actually identify those individual flows. So whether you're logged into a virtual desktop or coming in through remote desktop, in either case, we can identify the user. So it's a very important security feature. It's something that a lot of our customers actually do use this in production. And it's great for many different use cases and many different scenarios as you can imagine. So what are the requirements that we need? So Microsoft Active Directory is a requirement. It's the only LDAP-based directory. I guess in theory, at some point in the future, maybe some other open source LDAP might be supported. But the way it is right now, it's Microsoft AD, and you can see the list on the screen there. Another thing that's important is that in order for this to have the right hook in place, the virtual machine must have VMware tools installed with the VMCI driver, the virtual machine control interface driver. And if you kind of look down underneath that, you'll see the NSX file introspection driver and the network introspection driver. So those tools have to be enabled, or I should say those particular drivers have to be installed as part of your VMware tools install, which they may be but are not by default. So you have to check that or make that part of your default template, if you will. And then the guest and host operating systems that are supported. So the enforcement can be for desktop, Windows 8, Windows 10. We can do the enforcement across Windows server-based machines, be the most common, and also for the remote desktop enforcement. So as long as you have an RDSH server 2012 R2 or 2016, you're in good shape. And as of today with NSX-T, it's VM only. So we can't control enforcement out to a physical desktop. Maybe at some point in the future we'll have that. Back in V, there was some capability there, but it was not really consistent. So we're just going to be enforcing that for VMs only at this point in time. But it's a great feature in environments that support all these different components. It's very, very easy to implement and use, and can have some very, very good security benefits for your organization. Another feature that we have is the ability to look at our north-south traffic flows through our edges. So whenever a user on our network is trying to get to some particular URL, you may have used other third-party services for this in the past, maybe even your existing services from your Palo Alto to your checkpoint may have this feature. But again, this is something that we're bringing now into the kernel of your ESXi host that is once again distributed across your environment. And what I can do is track my users' access to particular URLs, and they get a reputation score. And these reputation scores are monitored based on the likelihood of the site being risky, something I might want to go to, may not want to go to, and it tracks those scores for me. And then we can actually create rules that'll enforce users' ability to not go to a particular site based on its score. So if I'm going to thebankonline.com, it's some well-known site that's known for phishing and it's got a very low reputation score. What I can do is, based on those scores, is build policies that I enforce, again, across my entire environment based on a certain range. And I can tweak those ranges based on how strict I want it to be or how loose I need it to be, depending on who's trying to get where, because there could always be exceptions to those rules. So it's yet another feature. So all these things start to add up. I'm getting the built-in security that I get with micro-segmentation for layer 2, 3, and 4. I'm able to look into the frame to get layer 7 capability with my App ID feature, which is improving and getting broader over time. And I also have the ability to protect my virtual desktops and my RSH connections into my remote desktop connections and monitor those. And now, in addition, we've added yet another feature for URL analysis. So all these things combined give you a rich set of tools that make NSX truly a security platform. Andrew, you want to talk about the time-based firewall policy?
Sure. So we also have a really cool feature where we can apply policy based off of a period of time. So if we want to, let's say, only allow access to a particular application during business hours, so let's say from 7 to 7 on Monday through Friday, we can actually control access to different workloads based off of the time period. So if we want to control, let's say, even administrative access to an application or to certain workloads to a certain period of restricted time, we could do that as well. It's yet another layer of added capability that we can have and added granularity to enforce rules exactly how we want them to be enforced.
Well, so that's pretty powerful. So now we can actually have a firewall rule and open something up, and maybe we're concerned about opening it. So now you're telling me I can actually go in and say, now it's only open for this period of time. That's pretty powerful.
Yep, not bad.
And then we have the restrictions where they can't get in. So yeah, definitely a very useful tool. So the great thing about this NSX security product, it just keeps getting better and better. And one thing I like to talk about on this is that it is a software-based platform for security. We're not dependent on any kind of hardware embedded upgrades or changes. So if you think it looks good now, it's just going to keep improving and getting better and better over time as the software improves and different revisions are released of the product. We have a brand new feature that's very exciting. It's called NSX Distributed IDS. So this is a feature that, again, may be something where you're using some type of third-party tool. A lot of these tools are agent-based, and they require you to install some type of an agent into your VM. And then you have to maintain that agent and make sure it's updated. Another thing about these agent-based tools that can be challenging is the version of the VMware hardware and VMware tools can be very important to those agents. Now, by doing a distributed IDS in the kernel of the host, we get that type of protection built right into the kernel, and it's distributed just like your firewall. So we have the ability now to have this intrusion detection-based system, detection and prevention. The IDS is now, IPS is coming out soon. Like I said, the product keeps improving over time. So with this IDS-based system, we're using a very well-defined, very well-known set of updated IDS algorithms and tracking mechanisms to be able to look at traffic flows and to detect some type of an attack that may be occurring. And then once we detect that attack, we can tag the VM. We can place that VM in a security group that's at the top of our list that doesn't allow it to talk to anything. So we can quarantine it and we can lock it up and make it so that it's separated. We can then determine what the problem with that VM is. We can clean it and then put it back onto the network. So before the NSX IDS IPS-based system and then with. So let's take a look at this before. We would have to send the traffic out to some external device, or we'd have to leverage some agent-based tool on our ESXi host. And there are throughput constraints. So whenever you start sending something out to some external device or leveraging agents on a system, it's going to slow things down. So imagine you have some kind of third-party rack-based tool like a FireEye or any other third-party tool you may be using that's a physical device, a Barracuda, a FireEye, something like that. We have to continually steer traffic in our rack out to wherever that device sits, somewhere else in the rack in our data center. So now with this included into the kernel, like magic, that's now baked into the kernel of our ESXi host. The great thing about this, it allows us to scale, gain more throughput, and eliminate those bottlenecks. It also helps minimize the chance that we're going to miss something that may not have been included within the scope. So it makes it much better as far as potential blind spots or missing particular workloads. Better performance. I can also move the VMs around. It doesn't matter what host the VM is sitting on. That IDS-based system is going to follow that VM wherever it sits. All this is going to help us with regulatory compliance. We can also set this up in particular zones, and we can create zones in software, very similar to the tagging that we saw, where something may be more specific or more granular than the others. We can do it for particular applications, and we can also help us with our virtual patching by moving. We can open something up and then block it down as we need to as we implement these different tools. So it's a great way to make sure that your environment is much more protected than ever before. Andrew, you want to talk about network introspection?
Yeah, so the last piece here that we're going to add in is the capability to do everything that we just talked about, but then add on top of that the capabilities of third-party firewalling services. So if there's something that NSX isn't doing that you desire from a third-party tool like a Palo Alto that you can or you want to bring in, you now can do that with NSX-T. So very similar to NSX-V, with NSX-T, we can also bring in those third-party tools, and right in line with our distributed firewalling and all the other capabilities that we have, we can add in that third-party capability with our partners. So if you want to take your firewalling to the next level, bring in that next-gen capability, other IPS capabilities, additional visibility, that can be added in at the individual workload level or at the tier 1 gateway that you're seeing in this drawing, or the tier 0 gateway, depending on how you have it set up. You can actually do it at the gateway level as well. So if you're looking for even beyond the capabilities of what NSX has, you can bring in those third-party tools, add in their capabilities right in line with everything that we've already been doing as well.
Yeah, another thing that's cool about this in NSX that they've improved is it used to be that you'd have to deploy an appliance on every single host, and you can still choose to do that if you want to, but those appliances do cost money. There's a charge for all the appliances you deploy. So what you can actually do now is have a centralized data plane for that enforcement. Now, there will be a little bit of a hairpinning where you can actually have those network introspection VMs running on a particular cluster or set of hosts, and the traffic does get steered to them. But in most cases, the throughput is usually adequate to support that, and that can minimize the footprint of how many appliances you have to deploy. So I don't have to deploy the appliance across every single one of my hosts going forward. You still can if you want to, but you now have the option to have that kind of centralized data plane to steer that network introspection into.
It's certainly a nice advantage to have.
And now we have enforcement with network introspection across all our workloads. The other benefit some customers like is if they're used to using their Palo Alto and they have a single pane of glass, they can now deploy the Palo Alto appliance and they can integrate that, and they can keep all their firewall rules in that one particular single pane of glass. And these are all the different vendors that we work with. So there's a lot of different options for integration. Hey, thanks, Andrew. That was a great presentation. Thanks, everybody, for joining this presentation today. That wraps up our security talk around NSX. Thank you for attending the VMware Cloud Networking Academy, and we'll see you in the next video.
Thanks, everybody.